Let's start with a premise, a way of looking at your own mind. Imagine that everything you think and feel, your entire consciousness, is a kind of technical stack. 4 layers.
Mm-hmm.
And right at the bottom, layer 1, you have the hardware, the wetware of the brain, neurochemistry.
Right. The fundamental biology.
And if that hardware has even a tiny chemical glitch, that error doesn't just stay buried. It surfaces immediately in layer 2.
It shows up in the code of your language.
Exactly.
And that is the core idea we're really getting into today. We're focusing on that second layer, what we're calling the linguistic operating system.
Our mission for this deep dive is to look at the brain's fundamental split, the dual stream hypothesis.
And we want to show how 2 huge, really competing theories of language actually map onto this physical anatomy almost perfectly.
We're talking about generative grammar on one side.
And systemic functional linguistics, or SFL, on the other.
Right. And here's the part that's really groundbreaking. We're going to show why SFL isn't just some abstract academic theory.
No, it's a tool. It functions as a diagnostic debugger.
A debugger that can spot the specific linguistic signatures of conditions like schizophrenia, depression, even autism. It gives you a measurable, quantitative readout of what's happening back down in layer 1.
It's a huge synthesis. And it provides really the technical roadmap for building what we're calling cognitive prosthetics.
And these aren't just, advanced chatbots.
Not at all. These are AI systems designed to stabilize human thought by understanding where the biological hardware is failing. We're moving from just describing symptoms to a kind of mechanistic explanation, using your own words as the raw data.
Okay, so let's dive into layer 2, this architecture that literally defines how we talk. When we talk about a bicameral language system, what exactly is being split?
Well, the key discovery is that language processing isn't just one big function. It relies on 2 totally distinct pathways, or streams.
Like a CPU with 2 cores.
That's a great analogy. You've got the dorsal stream, which we can call the how pathway, and then the ventral stream, which is the what pathway.
Okay, let's start with dorsal. The how. Where is it, and what's its main job?
So the dorsal stream is really the motor and structural path. It's mapping sound to articulation. It handles all that sensorimotor stuff.
The physical act of speaking.
The physical act, but also the structure, the geometry and sequence of language. If you need to figure out how to build a complex, grammatically perfect sentence, that's your dorsal stream doing the work.
So timing, sequence, grammar rules.
All of it. And neurochemically, this is really interesting, it relies heavily on GABA.
The brain's main inhibitor, the brake pedal.
Exactly. You need that inhibition for strict temporal ordering, making sure the right sound or the right word fires at the exact right millisecond.
Okay, so if the dorsal stream is the architect building the structure, the ventral stream, the what, has to be the librarian. It's dealing with meaning.
It is the semantic library. The ventral stream connects a sound directly to a concept. It maps that sound to this huge, sprawling network of associations in your temporal lobe.
And its chemistry must be different.
Completely. It's powered mainly by glutamate, the brain's accelerator. That glutamatergic activity is what drives the plasticity you need to instantly link the sound cat to the whole concept of a cat.
So this is the bridge from biology to theory. If the dorsal stream is all about innate structure.
It maps perfectly onto generative grammar.
Chomsky.
Right. Chomsky's whole idea of universal grammar, or UG, these innate, recursive, context-free rules of syntax. It's like the firmware of language. It only asks one question. Is this sentence grammatically correct?
And by that same logic, the ventral stream, which is all about context and meaning.
That has to be systemic functional linguistics, SFL.
Halliday's theory.
Precisely. For Halliday, language isn't just a set of rules, it's a flexible resource for making meaning in a social context. It's the software we use to get things done. SFL asks a different question. What is this sentence doing?
Okay, so now we can really see the failure state.
Yeah.
What happens when layer 1, that GABA-glutamate balance, goes wrong and these 2 streams decouple?
Let's use that analogy of the intellectualization defense mechanism. It's a classic example.
So say the meaning that the ventral stream retrieves is just too painful. It's connected to trauma.
Right. The feeling of abandonment, for example. The nervous system then employs a kind of routing strategy.
It reroutes the linguistic output.
Yes. The speaker retreats into what you could call dorsal overdrive.
Meaning they lean on pure structure.
Pure structure. They start using incredibly complex syntax, perfect grammar, lots of recursion to talk about the painful topic, but their language is completely sterile. It's devoid of any emotional content.
They're using their structural strength to bypass the painful meaning.
It's a form of verbal dissociation. The firmware is running perfectly, but the software is offline.
That connects so clearly to layer 4, to the AI we're building right now. It sounds like our current AI models are stuck in the same kind of trap.
It absolutely are, which is why the sources are so clear that the future has to be neurosymbolic AI.
Explain that. Our large language models are amazing at.
They're amazing at ventral-like generation. They're fluid, associative, semantic, but they have no grounding.
They hallucinate.
They hallucinate, they confabulate because they're based purely on statistical association. There's no structural constraint.
So what's the dorsal anchor for an AI?
It has to be a symbolic component, something like a personal knowledge graph, a PKG,
A fact checker.
a rigid, logical, fact-checking anchor. It prevents the statistical, ventral-leaning LLM from just making things up. The artificial mind, just like ours, has to be a hybrid to be reliable.
All right, let's move into SFL as the debugger. This is where we use language to actually measure the internal state. Let's start with the first of SFL's 3 metafunctions, the ideational metafunction.
Right. The ideational metafunction is all about how we use language to construe our experience of the world. And the main tool we use to analyze it is the transitivity system.
Which is basically analyzing who does what to whom.
Exactly. We look at the main verb, the process type, to see if the speaker is framing themselves as acting or sensing or just being.
And this gives us a direct, measurable biomarker for something like depression. Tell us about the transitivity shift.
It's really stark. In patients with major depressive disorder, you see this quantifiable drop in material processes.
Verbs of doing, acting, moving, changing the world.
The verbs of agency, they almost disappear. And instead, their language becomes saturated with mental processes, verbs of feeling, thinking, and relational processes, verbs of being.
So instead of, I fixed the chair,
A patient showing the shift would say, I felt unable to move, which is a mental process. Or even more directly, I am worthless, a relational process.
their grammar literally encodes a loss of agency.
It's a linguistic confirmation of that feeling of helplessness. It links directly back to layer 1 issues, to dopamine, to effort-cost calculations in the brain. You can diagnose a loss of self by just counting the verbs.
That's incredible. Now let's pivot that same analysis to autism spectrum disorder. What does the transitivity system show us there?
For ASD, we see something different. It's called the mental process gap.
A gap. So they use fewer of them.
Significantly fewer. Autistic speakers produce far fewer mental processes, verbs of cognition, affection, belief, compared to neurotypical speakers.
Which is objective linguistic proof for the whole theory of mind deficit idea.
It's strong evidence, yeah. They seem to struggle using language to describe these internal, unobservable states, either in themselves or in others.
So how do they describe those situations?
They often substitute. So where a neurotypical speaker might say, I believe he is angry, using a mental process, an autistic speaker is more likely to describe the observable action. They might say, he shouted loudly.
Describing the material world, not the internal one.
Exactly. The grammar stays anchored to what can be seen and heard.
Let's move to the second axis, the interpersonal metafunction. This is about how we build relationships with language.
Right. It's about social regulation, demands, offers, certainty.
Right.
And the critical system here for diagnostics is modality.
Modality being how certain we are.
Your degree of certainty, obligation, probability, it's the difference between I know, I might know, and I should know.
And why is analyzing that so important for cognition?
Because a lack of modality, when someone only speaks in bare declarative assertions, is the linguistic signature of rigid thinking.
This is the way. He will fail.
Exactly. It shows a kind of cognitive inflexibility and inability to entertain alternatives. The executive function you need to say, perhaps, or it seems, is often compromised when that flexibility is degraded.
Which is why you said we use SFL to enforce this on AI.
Yes, we force our AI systems to use low-certainty modality markers for predictions. We demand epistemic vigilance from them.
That's a great transition to our final axis, the textual metafunction. This is where the architecture of our attention lives, right? The layer that creates coherence.
Yes, and because of that, it's the primary tool for detecting acute cognitive fragmentation, what we call thought disorder, especially in psychosis and schizophrenia.
How do you measure that?
By analyzing cohesion, the little linguistic links that make a text hang together. In schizophrenia, you see these very specific measurable failures in cohesion.
Give us an example of what was called crazy talk.
The most common one is a reference failure. A patient will use a pronoun like it, or they, or say the thing, but they never establish what it or they or the thing is.
So I went to the store and it was missing.
And the listener has no idea what it is. You're forced to search for a referent that was never provided. It breaks the shared understanding between speaker and listener.
Which points right back to that theory of mind deficit. The speaker can't model what the listener knows.
Precisely. Another key one is a conjunction error. The patient uses logical connectors, therefore, but the clauses they're connecting have no logical relationship.
So the syntax is perfect.
The dorsal stream is building a perfect grammatical structure, but the ventral stream is feeding it incoherent content. The logic is hallucinated.
And the textual metafunction can also catch more common issues, like disorganized speech and ADHD.
Yes, through analyzing something called thematic progression. Every clause has a theme, a starting point that sets the context. In coherent speech, you stick to a theme.
You build an argument.
Right. But in ADHD, or even just under high cognitive load, you see thematic drift. The speaker just jumps from one theme to a completely unrelated one over and over. It's the linguistic fingerprint of a failure in task-switching regulation.
So we have the diagnosis. We can quantify the breakdown. How does that translate into a Layer 4 intervention, into the cognitive prosthetic?
It triggers specific personalized rules in the AI. Let's go back to our first example, that intellectualization defense, dorsal overdrive with ventral disengagement.
The system detects high syntactic complexity but low agency.
Right. And it triggers rule R2, the therapeutic recurring rule. The AI acts as a semantic debugger, a linter for your thoughts.
It doesn't tell you how to feel.
No, it forces a grammatical rewrite. If you write, "The crushing burden of hopelessness was carried by me," the system flags the passive voice, the abstract noun, and the prosthetic just asks, could you rephrase that in the active voice?
Yeah.
Who is the actor here? What did they do?
So it uses your own dorsal strength, your ability to follow rules.
To force you to re-engage the ventral stream, to translate that abstract pain back into a concrete action or a sensory experience.
That's therapeutic recoding. You're using the stable parts of the stack to fix the failing parts.
You're moving the user's linguistic center of gravity back toward agency and concrete reality.
This has been an incredibly dense, deep dive. I think the core takeaway for me is that language isn't just some abstract thing we do. It's the measurable, quantifiable bridge between our neurochemistry and our ability to think coherently.
By applying the SFL framework, we can quantify these fundamental mental states: agency, coherence, flexibility, with a precision that moves us beyond just symptom checklists. We can create objective, mechanistic linguistic profiles.
In looking forward, this whole synthesis of the two streams, the dorsal, symbolic logic, and the ventral, fluid meaning, it points to a really profound future for technology.
I think so.
We're not just trying to build an artificial intelligence that thinks like us.
We're moving towards intelligence amplification, IA. The goal isn't to replace the human mind, but to build a cognitive prosthetic that can monitor and help stabilize our own, inherently fragile dual-stream consciousness.
An external system admin for our brain.
Constantly working to restore that neurolinguistic balance when our biological wetware inevitably glitches. And that, I think, is where the real power of this whole framework lies.